Hi everyone, thanks for checking out this video. So this is the second video I'm making in this series on this PyTorch image classifier for melanoma images. So I previously made a video that was like a quick introduction showing you guys like what the finished like final version is going to look like. And then in this video we're going to get into some actual coding, and this is going to be a video about how to download the data, like where to find this data set. How to download it, and then how to process the images into the format that we're going to need to begin using them to train our machine learning model. So yeah, this video is going to be, we're not actually going to be getting into any of the PyTorch yet, but this is actually like one of the most important and sometimes one of the most difficult parts with machine learning is just finding a data source and then processing the data to get it to where you need in order to actually like train your model. And then actually you guys are going to see that like this is kind of the hard part, and then writing the PyTorch model is actually going to be like pretty easy. But yeah, so let's get started with this data set. So the data set I'm going to be using is this melanoma skin cancer data set from Kaggle. So if you guys don't know it already, this website Kaggle has a lot of these cool like machine learning data sets that come like nicely packaged and like nice and like easy to use. Some people don't like Kaggle because they think that it makes it too easy to the point that it's like unrealistic. And I kind of understand where they're coming from, because if you guys are doing like real research, it's really never going to be as easy as like getting one of these like nice, clean, like nicely packaged data sets that has everything you need already. It's going to be a lot more difficult to like find the data set and get it to this kind of nice format. But I do think Kaggle can be great for like learning and for practice, because just because of how easy they make it in terms of like making all the data available for you. So yeah, they have a ton of different cool machine learning data sets, and I'm going to be using this this melanoma image one. So if you guys haven't downloaded it already, I'm just going to click download over here. And I think it's actually going to have you like register for an account and stuff. So I've already done all this stuff, but yeah, if you guys don't have an account, just create an account. And then yeah, just download this this data set. I already have it on my computer over here. So yeah, I think it's going to come in this like zipped file called melanoma cancer data set. And if we look in here, it's going to have like two folders called train and test. So if you guys kind of know like the basics of machine learning already, you usually split the data up into a training data set and a testing data set. So the training data set is what you use to like fit the model parameters and like, yeah, train the models, basically what it sounds like. And then the testing data set is what you use to evaluate the model's accuracy, because you can't be evaluating using data that it's already been trained on, because that'd be like cheating. So you want to test the model using data that it hasn't already seen before to see if the model's like generalizing properly, basically. But yeah, so if we look in train, it's going to have a benign folder and a malignant folder. So, and yeah, these both just have a bunch of like images. So these are the benign ones. These are the ones that are not melanoma. These are just moles on the skin that are not cancerous. And yeah, it's got a lot of them. You can just kind of take a look through some of these. But yeah, these are the benign ones. And then malignant has the ones that are actually melanoma. These are the actual cancerous moles. Yeah, we can just kind of like take a look here, see what we're working with. Yeah. And then if we go to the testing data set, it's the same thing. We again have the benign. Yeah, these are the ones that aren't cancerous. And then we have the malignant, the actual cancer ones. Yeah, so that's what we have that we're working with here. Okay, so now what we need to do is just like read all of these into a Python program and package them so that they'll be in the proper format that we can then use them in PyTorch and like train our model on them. Okay, so in this video, I'm not going to be using actually PyTorch at all, because I'm just trying to, again, just like make the input data sets. So I'm going to be using these libraries though. So OS, CV2, that's like an image library, matplotlib.pyplot. So you don't really need that. I'm only using this so that we can like look at the images and see what's happening with them, and then NumPy, and then I put the link to the dataset up here. But you guys can also find it. You guys can also find it by just googling Kaggle melanoma dataset, and it's like this one down here, melanoma skin cancer dataset of 10,000 images. But yeah, here's the link here too. Okay, so let's get started with writing some of this code. So the first thing I'm going to do is I'm going to define this variable called image size, and I'm going to make this 50. So basically, all of these images could potentially be in like different sizes, and we need to get all of them to be the same size because yeah, when we go to like input the images into our machine learning model, we need them to all have the same dimensions because we need them to all fit properly as inputs into our PyTorch model. So I'm going to make all these images 50 by 50 pixels by 50 pixels. So I'm just defining this variable at the top just to keep track of like what size I'm making them, because I'm probably going to need to be like using this same variable in a couple other different files we're going to be doing later on. So I'm just going to say up here 50 by 50 pixels, and then pretty soon we're going to actually like resize the images. But before we do that, I'm just like writing this at the top just so that if I need to look it up, it'll just be right at the top so that I can find it. But yeah, we're just defining this for now. We're not actually going to resize anything quite yet, but we'll get to that soon. Okay, so then the next thing is we need to just define like the locations of all the folders we're going to be using. So I'm going to say locations of image files. Okay. So then I'm going to call the benign training folder just ben training folder. Ben short for benign here. Remember, those are the ones that aren't cancerous. They're just like regular moles. And that's going to be in melanoma cancer dataset /train /benign. I always spell that wrong, but yeah. Benign. Okay. And then slash. Okay, so I think it's going to be the same for you guys if you don't change anything. Yeah, because this is what it's called when you download it from Kaggle. And then, yeah, train, and then benign. And then we want to do the same thing again here, but for the malignant training data. So I'm going to say mal, short for malignant. And then same thing, melanoma cancer dataset, train, and then malignant. Need to make sure I spell everything correctly here. Okay, and then we need to also define the testing folders. So yeah, those are going to be the same, except it's just going to be testing here. Okay. So now what we need to do is we need to write some code to like open up these folders and then convert the images into like Numpy arrays that can then be used for the actual inputs into the model. So yeah, basically now we're just trying to write some code to like open up these folders and like iterate over all the images and then save each image as a NumPy array that we can then use for training our model. Okay, so we're going to use the OS the OS library that we imported to do this, to iterate over the images. Okay, so the way we're going to do this is we're going to say for file name in os.listdir ben training folder. And then just to show you guys what this is doing, I'll print out the file name. But yeah, this is basically just iterating over all of the file names in this directory. Yeah, see, it's using the OS library to just like iterate over all these file names. And then for each file name, we want to define like the full path to the file as being this path like to the folder plus the actual file name. So this again is basically just, I'll show you guys what this is doing here. Print path. So yeah, this is basically just like writing the whole path to the file. See? And then now that we have these full paths, we can use these to actually read in these images. So I'm going to say image equals CV2. Remember, this is our like image library that we're using. Read path, comma CV2 dot read grayscale. Yeah, I'm making it grayscale just to make the images like easier to work with for now. Although if you guys were doing some kind of like professional research project, you'd have to make a judgment call about whether to make all the images grayscale or not. I'm just doing it to make it easy for this tutorial. But if you were doing a project where like the color of the image actually mattered, you may want to like not do it grayscale. Yeah, you may want to read it in color if you think the color is going to be important. Okay, so let's just try looking at one of these images when we've read it in. So to look at the image we just read in, we can use matplotlib like the PLT. We'll say plt.imshow the image, and then plt.show and then just break after that because we'll only want to see one for now. But yeah, let's just see what it looks like basically. Yeah, so you guys are probably thinking this doesn't look like it's gray. Yeah, that's just kind of one of the weird things about like matplotlib visualizing these things. It doesn't actually come up gray when we plot it in matplotlib. But yeah, it has been converted to grayscale at this point, so it's not capable of like representing like different colors. Okay, so moving on. The next thing we need to do is, like we said, we want to like resize all these photos to be, if they're not already, that we want them to be 50 by 50 pixels. So I'm going to say next, image equals cv2 dot resize image, and then image size by image size. Okay, and if you guys wanted to like check and make sure this is actually working, then you could just run this code again, like down here. Just look at it again, make sure it actually worked. But I don't think I need to do that. I think I'm fine for now. And then at this point, what we want to do is now basically like convert this to be an like a Numpy array, and then save it. So yeah, whoops, I actually forgot something important up here. We need to define some empty lists that we're going to be like saving everything in. So I'm going to say ben training data equals empty list. Then I'll say the same thing for mal training data. Remember, that's our malignant training data. And then same thing for the testing. We just want to be able to save these things in some empty lists, basically. So I'll say ben testing data, mal testing data. Okay, so now what we want to say is ben training data dot append, and then so we're going to append a list of two things. So the first thing is going to be a Numpy array version of our image. So basically just like taking the like pixel matrix representation of the image and saving that as a Numpy array. Yeah, you know, just to show you guys what this looks like, I'll actually do this separately. So I'll say image array equals np.array image, and then I'll just print out, like, just to show you guys what we're doing here. I'll print out this thing, and then I'll also print out the shape of it, just so you guys can see. Yeah, so do you guys see it? It's basically taking like the pixel like matrix representation of the image and then saving that as a Numpy array. And remember, we made the image 50 by 50 pixels. So what we're getting here is a 50 by 50 Numpy array where each element like represents a specific pixel and like how bright that pixel is, basically. And remember, it's grayscale, so we only have one number per pixel. That's why I made it grayscale. If it was in color, we'd be having like three numbers per pixel representing the color. But yeah, I didn't want to do that, so I made it grayscale. Make it simpler. But yeah, so that's the first thing we're saving is this NumPy version of the image. Whoops. Yeah, say image array. And then the second thing we're going to save is what's called a one-hot vector that tells us whether the image is benign or a melanoma. So I'm going to make it so that the one-hot vector of 1, 0, that's going to be the code for the benign images, and then the opposite 0, 1. That array is going to be the code for the melanoma images. So you know what? I'll put that at the top too. So I'll put one hot vectors 1, 0. Whoops, make this a comment. Benign 0, 1. Melanoma, just so we can keep track of it. Yeah, so I think that's, sorry, there's one more thing we need. Here. So we're going to actually put this whole thing in a try except block. So we're going to say try to do this, but then sometimes when you're dealing with these like image libraries, they have problems with them. So we're going to say like tell the code like try to read in and save this image. But if you can't, accept pass. So basically try to do it, but if you run into any problems, like the image is corrupted or the image, like, I don't know, it just can't be read in properly, then just skip it. Because we have enough that if any of them are like corrupted or something, we can just skip them and be okay. So yeah, we're going to put this whole thing in a try except block. Okay. So yeah, that's all we need for this one. But remember, we have three other lists we need to fill up. So this is good for the benign training data, but we need to get the malignant training data and then both of the testing datas. So what I'm going to do now is just copy and paste this whole thing. Just copy and paste this whole thing. And then the next one is going to be the malignant training folder. So I'm going to say mal training folder mal. Just need to change everything here. Mal training data. Did I get everything here? Yeah, I think we're good. Okay, so that now we have both of the training data sets, but now we need to also get the testing data sets. So I'm going to just copy and paste both of these things here. Just copy and paste both these things. And then, okay, so what we have to do now is just make these testing. Okay, testing folder. Okay, testing. Okay. Testing. 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 Okay, so we should be good. So we have benign training, malignant training, benign testing, and malignant testing. So we're basically, yeah, filling up all four of these data lists that we need. Okay, so what we need to do next is just check in, like, see how many we're getting read in of each of these images, because we want especially the training data to be kind of balanced, because if we had like a lot more of like one of the types, like let's say that our training data was like 95% benign, then the classifier could become like reasonably accurate by just like guessing benign every time. You could get like 95% accuracy just by like guessing benign every single time without even having to learn any kind of pattern or anything. So we don't really want that to happen. So we want to make sure that like that the data sets are somewhat balanced. So at the end here, I'm just going to try like printing out the lengths of all of these lists to just see like how many images we're getting like for each of these, to make sure they're like somewhat balanced. Okay, so let's give this a try. Whoops. Okay, sorry guys, I made a mistake here. Okay, I already know what this mistake is. This should not be testing. This should just be test. Okay, sorry about that, guys. Yeah, I made a mistake writing these paths down. Sorry about that. Okay, so it looks like our testing data sets are pretty balanced. Yeah, it's just 500 of each, but we have a little imbalance in our training data sets. We have more benigns than malignants. So yeah, I think what happened was that probably some of the malignant images were corrupted and they didn't get read in properly, because it was supposed to be like 5,000 of each, but yeah, this one, it didn't exactly have 5,000. So what we have to do here to balance it out, what we're going to do is we're going to say we're basically going to shorten the benign data set to get it to be the same length as the malignant data set. So I'm going to say ben training data equals ben training data from 0 to the length of malignant training data. So this is basically going to just chop off a bunch of the it's going to chop off about like 400 of the benign images just to get them down to be the same length. So I'm just going to run it like one more time to show you guys. Yeah, when we add this line, this is going to make us have the same amount of benign and malignant training images. Also, whoops, guys, I forgot something super important here. It's a good thing. Okay, it's a good thing I caught myself on this, because this would have been a huge problem if I hadn't caught it. So I forgot to tell you guys, we need to change the one-hot vectors too. So yeah, good thing I caught this, because this would have been a huge problem if I hadn't caught this. So we need to make the melanoma one-hot vectors 0, 1. So yeah, we need to change these down here too. The melanoma one should be 0, 1, because basically like what we're doing, reading these things in and saving them in these lists, is that each element in the list is first a Numpy array representing the image, and then second a label of whether the image is benign or melanoma. And we need to make sure that the labels are actually different. We can't have them. Yeah, that would have been a disaster if I hadn't caught it. So good thing I caught this thing. But yeah, the one-hot vectors for the melanoma ones are going to be 0, 1, and then we're just storing that as a Numpy array. So yeah, just to repeat myself, just because I missed this the first time through. Yeah, just make sure that you're changing these one-hot vectors to be 0, 1 for melanoma, and just keeping them 1, 0 for benign, because those are basically the labels for what type of image it is. But yeah, so I changed that, so it should be good now. Yeah, sorry for missing that the first time through, guys. But yeah, besides that, looks like we're in good shape. We have the same amount of benign and malignant training images now, and then same amount of testing images. So yeah, what we have to do next is just like merge the training data sets together. So we want to say training data equals ben training data plus mal training data, just merging them together. And then I'm going to say np.random.shuffle training data. So this is basically just like shuffling up this data set We want to get it nice and mixed in so that it's not all just a bunch of benign images followed by a bunch of melanoma images. It should be kind of like shuffled up. Yeah, shuffle it up, and then we're gonna then save it as a NumPy object. So we're gonna say save melanoma training data.npy, saving it as a NumPy object, and then training data. So yeah, basically just saving it, and then we then want to do the same thing for the testing data. So ben testing data, mal testing data, testing data. Okay, make sure I got everything. Okay. Yeah, so for me, it gives like a warning. It gives like a warning down here, but this is not really an error. So we can see that it actually still worked over here. So maybe this is like not the best practice, but I've actually just been kind of ignoring this warning for now because it appears to like still be working and giving me what I want. But yeah, we can see over here, it worked. It saved these training and testing data sets as NumPy objects. And remember, in these data sets, like, these are basically just like big lists, although I guess technically now they're like NumPy arrays. But basically every element in this thing has two parts. So the first part is the NumPy array representation of the image. And then the second part is this label, the one-hot vector label, that tells us whether it's benign or melanoma. But yeah, now that we have these saved, now we can then we can read them into other programs. So basically, that's all we're going to do for this video. But in the next video, we're going to be continuing to work with these data sets we just made, and we're going to be defining a PyTorch model, and then using these data sets to train the PyTorch model. But yeah, that'll be in the next video. So yeah, that's all I have for you guys for now. So thanks for watching, and see you guys next time.